When you need mealtime inspiration, it's worth shopping Baker's, where you'll find over 30,000 mouth-watering choices that excite your inner foodie. And no matter what tasty choice you make, you'll enjoy our everyday low prices, plus extra ways to save, like digital coupons worth over $600 each week. You can also save up to $1 off per gallon at the pump with fuel points. More savings and more inspiring flavors make shopping Baker's worth it every time. Baker's, fresh for everyone. Fuel restrictions apply.
Are you enjoying the Single Tracks podcast? Well, we could use your support. The small but dedicated Single Tracks team works hard to share the mountain bike information that inspires epic adventures through this podcast, our worldwide database of trail maps and photos, and daily news and reviews on the website. So, consider becoming a monthly, annual, or lifetime pro supporter and enjoy ad-free browsing on the website, free Single Tracks stickers in the mail, and discounts on merch for as little as $3 per month. Go to singletracks.com/support to sign up and to find out other ways you can help support our mission. That's singletracks.com/support. Thank you and happy trails. Hey everybody, welcome to the Single Tracks podcast. My name is Jeff, and today my guest is Mike Bush. Mike is the president of Stan's, a brand whose founder, Stan Koziatek, pioneered the use of tubeless tires in mountain biking. Today, the Stan's brand designs and markets its own line of popular wheels and tubeless tire accessories to keep mountain bikers rolling. Thanks for joining us, Mike.
Yeah, thanks for having me. It's great.
Well, it's been almost 20 years since Stan first designed his tubeless tire sealant. What has it taken to get us to this point where tubes are pretty much all but forgotten in mountain biking?
Yeah, it's been a long road. I would say the number one thing that's gotten us to this point is just simply rider demand. You know, we started, early days. UST had just come out. Stan had some existing wheels that weren't UST. He thought tubeless would have been a pretty cool thing to have on his bike, but there were limited tire options and weight was a factor, and a bit of a weight weenie in those days and so on. And he was looking for that better way to do things, kind of with what's on hand, or can we create something and so on. And he started playing around with different, very basic sealant formulations at the time and how to seal an existing spoked wheel to be airtight. And, you know, as that word got out and they were doing, he and his wife, Cindy, that started the company, were doing some racing on the East Coast. You know, other racers hear about it, eventually pro riders hear about it. Of course, they were trying it and sort of sneaking it. They didn't want other people to know. But once you experience tubeless and a self-sealing type tubeless system of that nature, there's no going back. Of course, trials and tribulations in the early days, early pioneers and so on, but it was that rider demand. I mean, nobody likes a flat tire. There's never a good day to have a flat on the trail in a race, et cetera.
Right.
So,
right. Well, even in the early days, though, was it like as reliable as it is now and like as much of a no-brainer? Or back then, was it like there were maybe more trade-offs or like it was a little riskier? How have we gotten to this point where everybody just kind of accepts like, yeah, that's the better way to go?
Yeah, I think more difficult for sure in those days. Tires weren't designed for it. We were adapting a lot of standard tube-type tires to the tubeless application. By way of modifying rims, essentially.
Right.
So rim design has come a long way. We've been a big part of that. And, as riders push their limits a little bit, they're always seeking a better version. You know, mounts easier, inflates easier, so on and so forth. But it's like any new innovation, technology product. You know, you have to cross that chasm, as they say. Great book on that. You've got to get the early adopters going and moving along, and that helps you chase the majority, and eventually it spreads.
Yeah. Well, to a lot of us, tubeless tire sealant is basically just like magic. So can you give us a high-level explanation for how the stuff actually works, how it actually seals a puncture in a tire?
Sure. Our sealant in some ways is not different than a lot of others. We go about it in a different way, perhaps, but effectively what you're doing is using a liquid or something close to it to transport some sort of particulate to the puncture site. So for us, we like a very thin, sort of milky consistency because we want to have the liquid reach the puncture very quickly. So when you have that puncture on the trail, we want it to flow fast as the liquid The liquid enters the puncture site, and the nature of the latex is that it effectively is clotting when it's exposed to the outside air. There's a pH imbalance going on there, and begins to clot, and those particulates, or like the platelets in your blood or something, are following in and clogging the hole. So effectively, you're using that air pressure to just jam that hole full of stuff and allowing the outside air to begin to cure it.
Yeah. So it's actually, I mean, it's partially like a physical process, like something is jamming the hole, but it also sounds like it's a chemical process. And you're saying that the air outside the tire is different from the air inside the tire. How's that happen?
You have a highly humidified environment and so on that you're dealing with when you have that liquid introduced to the tire, there is outside air every time you inflate the tire and so on. That's what's causing it to slowly dry out, and you have evaporation taking place through the casing and so on. But every time you introduce that air, we'll probably get into this a little more, but a CO2 or something of that nature can cause that reaction to start taking place. And of course, there's a lot of CO2 around us in the outside environment. So that's exactly the chemical nature of it. And then, like I say, the physical is you're just trying to jam as much stuff into that hole as you can.
Interesting. Well, these days, there are obviously a lot of competitors in the tubeless sealant space. And one of the things that some of them are doing is like claiming to offer a more environmentally friendly solution or offer some kind of performance boost over sort of these more mainstream tubeless sealants like Stan's. So has the Stan's sealant formulation changed much over the years?
If you go all the way back to the beginning, 2000 or so, yeah, it's changed since then. The very first sealant products we were selling were literally just some natural latex that other people seemingly couldn't access as easily around the country. An instruction sheet that said add some water and some windshield washer fluid, and good luck. So that was effectively what sealant was in 2000. It did work, obviously. We wouldn't be here if it didn't. But since then, we've taken a deep dive on the chemistry side of things, and we source the latex from a different place now, and there were adjustments made to the chemistry of what we purchase in that sense, and we use some different additives than we did in the past that are food grade, safe for the environment, so on and so forth. Those have all been incorporated. The particulate has largely been the same through the years, but we added something to the commercial product line, which was our race formulation a few years back, something we always tested with our pro teams and worked on and so on. And that was kind of always the next level stuff. So under our SRD, or Stan's Racing Development tag, we eventually brought that race formulation to the masses, which has been incredibly popular. Unfortunately, we mix that one basically by hand.
Wow.
It's not something we want to make a ton of right now, but it is very, very effective as that race day sealant, and that carries twice as much of our regular particulate and then an additional larger particulate for the really big punctures. The downside is a bit more maintenance intensive. You can't put it through the valve stem and so on. So it's not for everybody, but that's just one example of sort of a formula addition, maybe not a change in that sense, but we've adapted to the needs of the customers in that sense.
Yeah. I mean, what other kinds of trade-offs do you have to consider when you're designing a tire sealant? I mean, I imagine, if we wanted like the most environmentally friendly thing, like it would basically be water, right? And it wouldn't work. So like what other kinds of things like that do you have to consider that you can't really change, because then it wouldn't work as well?
Right. So you have to have that clotting agent of some sort. Some old school sealants were just basically a gelatinous mess that just tried to fill the hole and so on. Very sticky. Tire shops didn't want to touch them, that sort of thing. So as that kind of automotive influenced product is, fallen out of favor with the bike crowd, you see these thinner sealants and things that flow nicely and carry the particulate, and we all enjoy the environment we ride our bikes in and like being out in it, and we have, I think, across the board a pretty good sense for the fact that that's what our customers want too, is environmentally friendly stuff. So we look at the additives that we use in that sense, but the big trade-off you have to make there is longevity in the tire versus puncture protection. So our take is that puncture protection is a must for sealant. There isn't much reason to use it otherwise. The longevity balance comes in with, sure, we could make it last a really long time, but you decrease puncture protection there. They are, opposing variables there. So what we try to do is strike that balance with our standard formulation. We could make it last a little longer, but you'll just puncture protection, so on. We wanted the enhanced puncture protection, so we brought the race formulation out, where it doesn't last as long. It dries out a little bit quicker. It has a tendency to sort of snowball inside the tire with those larger particles. And then it requires that more maintenance we mentioned previously. So it's really that longevity versus puncture protection. Some people have a different take on it than we do, but we want to make sure we can seal the hole first.
Yeah. So several years ago, it seemed like a lot of the brand new tires that people would buy kind of off the shelf would just leak sealant through their pores. Have tire companies had to adjust their formulations and manufacturing processes to improve tubeless performance, or is it the other way around? Have the sealants had to adapt to sort of how tires are put together?
I think it's a little bit of both, for sure. Tire companies have been making a lot of improvements on all sorts of aspects of our modern day tires. There's no question. What you referred to there, we would just call it seeping, where you're seeing some component of the sealant seeping through the sidewalls. So I can't speak necessarily to the specific actions they may have taken. Obviously, so many tire manufacturers out there with different approaches to things. But we do private label for several tire manufacturers and produce tire sealant for them. And we know that they have done some things, whether it's in formulation, it could be in the mold release, the type of airbag they use during the molding. There are things we did with some tires we had produced years ago. Obviously, we didn't make them directly. They were made for us, but working with that manufacturer to reduce the size of the font on the lettering that's required to be molded into the sidewall. So you have that tire casing that's coated in rubber, and when you mold the tire, it's a negative space to fill those letters, so it draws that rubber off the sidewall, off the casing. And the more it does that, the more it can leak through those spots. So we just simply reduce the height of the font. It's a required marking, so move as much of those markings onto the tire hot patches, so where your graphics and so on are contained. That you're legally allowed to do, just to eliminate potential leak sources. And we did some other interesting things that weren't necessarily production possibilities, but we learned a lot about how that can seal better. And then again, on the sealant side, and these private label manufacturers and some others we've talked to, they would see seeping from customers, and of course they treated it as warranty claims and wanted to know what we could do about it. And looked into it and adjusted a little bit, but honestly, we don't get that complaint a lot. We didn't back then, and we don't today. I think in part, if a tire manufacturer has their own sealant brand and their tire, there's nobody else to call if they're leaking through. Right. If it's the sealant or the tire, well, either one of us could get the phone call with different brand names on them. So we haven't seen a lot of that. I mean, in personal use, sure, we've seen the wet spots from the seeping, and there are a lot of improvements made at the tire that have certainly contributed to reducing that seeping. Yeah.
Well, obviously everybody agrees that flat tires suck when you're mountain biking, and going tubeless obviously is going to reduce the risk of that happening on the trail. And one of the things we're seeing today is a number of companies offering tire inserts as sort of another partial solution to flats and rim strikes. What's your take on these products?
I think tire inserts are pretty interesting as a whole. They're obviously not all created equal. Some have different intents and purposes and so on, and convey certain benefits to the riders. Some are more XC focused versus the enduro and downhill focus that would maybe of the earlier products. I think there are a number of positives that come from insert use. That's not to say everything's perfect, though. We had done some early testing with one particular insert and found in impact testing, we do some pretty aggressive impact testing, I'll admit, but in some of that impact testing, we would see what was normally a very direct point load with like a wedge type anvil. Okay, the rim dents are pinch flats and so on, depending on the tire construction and so forth. When the insert was introduced, we didn't see that direct point load, very sharp impact, but we saw it dispersing that energy over a much greater space. Ultimately, that's the goal of the insert, to protect your rim. But it would actually create this large flat spot in the rim rather than this just simple dent. So a large flat spot's much harder to take out of an aluminum wheel after the fact.
Yeah.
It's largely garbage at that point, scrap metal. But a simple direct point load impact, a lot of people, right or wrong, will bend that back and use the rim until they get a second or third incident along those lines. So we did see that happening a bit. And one of the other insert issues we've come across, not too many of them actually absorb sealant. It can happen, of course, if it's more of an open cell or porous foam that's being used. But depending on how it contacts the sidewalls, how far up the sidewall it actually reaches, whether there's any channeling or anything integrated to the insert, is it will prevent sealant from reaching those lower portions closer to the rim. So it is still possible to pinch flat with an insert installed, just as it's possible to pinch flat a tubeless tire, even though there's no tube involved. When that happens, you can't get sealant to that puncture unless the insert has some channeling or something. And not all of them do, and not all of them make a lot of contact with the sidewall. But some that do, that can be a challenge. I think the modular nature of an insert is really nice. So if you like them and want to reuse them, just add them to your setup. If I don't, I can leave them out. It's it's pretty convenient. What happens a lot of times with like our EWS team, one of them sponsored by Cushcore and the GT team. Martin May is one of the top riders in the world. He'll run a lighter front wheel. He'll use our Mark III front wheel without an insert, and he'll run our heavier duty rear wheel, the EX3, the Flow EX3, with a Cushcore insert. It tends to be harder on rear wheels. Those guys are approaching some crazy speeds on some tough terrain. That's the setup that works for him. So he doesn't have to run the heavier tire on both ends or do different things that way. He can really tailor his setup to his needs. And, that applies to the rest of us too. So I think that modular nature is really good, really good.
Yeah.
I would also say, though, that inserts to me, I personally had a kind of a negative reaction when they first came out. Was this looks like a Band-Aid to a system that should have better rims and tires.
Right. Yeah. I mean, that was going to be my next question was sort of, is there a better way to address the shortcomings of tires and rims that doesn't involve inserts? And also, hearing you talk too, I'm wondering if now that inserts exist, now that it's a thing that people are running and some of them are choosing to run, does that influence rim design at all?
Yeah, I think it does and can continue to influence rim design, and it'll probably influence tire design. We see a lot of new casings, whether it's from Schwalbe or Maxxis or what have you, some of the bigger ones to come along. Kenda has the Apex type inserts as well, which is that butyl insert just above the bead. And they're trying to do some of what inserts do, which is protect from pinch flats. It doesn't necessarily bring the stability and so on that these purported benefits of other inserts, but certainly there have to be better ways to do what we're doing today. There's always a better mousetrap down the line somewhere.
Yeah.
We'll have some R&D projects continuing in this field as well. Again, pinch flats you can deal with sealant or with plugs and so on, but ultimately it's better if they don't happen.
Yeah. Yeah. Well, it's interesting too that you mentioned, in your tests, sort of finding the mode of impact and damage is different when someone's running inserts. But I guess I also get the feeling from you that doesn't affect sort of your, warranty process or like even your recommendation to riders, like should they run them or not? Is that a factor? Is that something that people should consider or that you consider as a brand? We
haven't changed any stance on warranty or anything of that nature. I mean, there are so many it's like sealant brands. There are so many of them out there; it's hard to keep up with. It's the same thing with inserts, and we'll never deny somebody a warranty or a crash replacement or something because they used an insert instead of not. But I think there are certain instances where they might have been better off without it.
Yeah. Interesting. Well, tell us a little bit about how rim designs have evolved over the past several seasons. For a while, it was about widths, and I know Stan's offers a wide range of rim widths, internal widths we're talking about. But yeah, kind of walk us through how rim design has evolved recently.
Yeah, I think the width thing certainly went crazy. That's what mountain bikers like to do. We go to an extreme and then have to back off later.
Yeah,
for the most part. We produced a rim that was 50 millimeters wide at one time, and not necessarily for fat bikes and that sort of thing.
Wow.
Yeah. Well, we probably still have some if you need them, but I think there's always a focus on weight. Nobody likes carrying more weight around than necessary, but that's gone a little bit by the wayside. I think it will come back to some extent as we started chasing width. The desire was to keep the weights in the same range, and we said, you can't have both. You're going to lose some durability here if that's really the case. And today's bikes, and from XC through downhill, really have a strong focus on durability and reliability,
right?
And not cutting every gram. So I think there's some stuff going on there. We've had better access to more advanced alloys. Almost all of us are dealing with an Asian supplier for extrusion or rims. Select few options in the U.S. and within Europe and so on, but just better alloys there have helped us deal with that weight issue. And can we do thinner walls, sections, and things of that nature?
Yeah.
Better processing and manufacturing to control tolerances have been a factor in improving rims the last few years. And obviously the big one for us is an even better understanding of how that tubeless seal is created and maintained between the tire and rim. Mm-hmm. I think it's been big for us. Obviously, that's what we based our whole rim and wheel design around. But a lot of other manufacturers have brought that as well. So I think 10 years ago, and maybe we were one of the 2 or 3 tubeless rims that really worked, and now it's hard to find one that doesn't work at least pretty well, honestly. Not all of them are perfect. I think there's some that are actually kind of bad, but at the same time, the vast majority are pretty good these days. I think you're seeing more rims now that have just the flat bead seat, which is something we've done from day one. So that portion where the beads actually rest when the tire is inflated. The UST design that was the first to tubeless had the large bumps on the bead seats. Mm-hmm. And a lot of people followed suit with either a UST license type design or something like it. And the newer rims now from even on the road, Zip and Mavic and so on have done away with the bumps. We all know that they aren't really necessary. Mm-hmm. I think you've seen a lot of rims with some shorter sidewalls, which is, again, something we pioneered. So I won't toot our horn there, but that's where a lot of our IP is based. We have 7 patents in the U.S. around short sidewall designs and so on. Wow. So I think we've seen a lot come that direction, and that allows for the tire to take a more natural shape. And the further you move that sidewall down, the less chance of pinch flatting, and you reduce the leverage on the center of the rim so you can make a thinner section and so on and so forth. So I've seen that on some other rims out there. And then probably the big one would be the straight side or hookless designs. Mm-hmm. That's obviously happened in the last few years. And starting with the carbon rims in particular, because it did allow for easier and better molding, easier manufacturing. So that's come, I would say, a long way. And the realization that hook at the top didn't really help with tire retention. That comes from a properly sized rim and tire. The hook isn't necessary. And obviously, you see it on some aluminum product and so on. Now, where for manufacturing, it doesn't make a big difference, but it can still allow the tire to take a better natural shape. And you can run a little bit thicker sidewall to help preventing pinch flats, that sort of thing.
Yeah. Yeah, it seems like the rim, sort of the bead socket, if you will, is kind of the point of differentiation in terms of like a tubeless tire setup, because it seems like that's a really vulnerable point where you're going to be getting flats from pinch flats or burping. Is that kind of what Stan's has found over the years?
Yeah, we actually, had termed our little portion of that rim, so bead seat to sidewall, and the lack of a large bulbous type hook on there as a bead socket. We envisioned that, checked and measured, of course, but that a tire bead is interacting with the rim in more of a socket fashion rather than, if you look back at old patent drawings and even old marketing information, you'll see this bead floating off of the bead seat and being retained by the bulbous hook and so forth. And we refer to that as like the bead float gap. That does happen if things aren't sized properly.
Yeah.
And we've backed that up with CT scans and so on to see how much and how different it can be with the decentering of the tire on the rim.
Yeah.
It does happen. So that bead socket is the critical point of interaction between the tire and the rim, and something we focus on, not solely, but very much so in our designs.
Yeah. Before we move on from talking about rim and rim designs, is 30 millimeters sort of that width becoming pretty standard for mountain bike applications? I mean, it seems like we're seeing, new bikes that come out from XC to Enduro, really, they're all right around 30 millimeters. Do you think there's sort of consolidation happening around that number?
Yeah, I hesitate to say standard. That's a real word in our industry, right. But
it could be good or bad, right? I mean, we need standards, but not a lot of them.
Yeah, it does seem that things have gravitated toward 30. I've been riding for 25 plus years now. Kind of hurts to say, but cross country back then was a 1.9 tire, 2.0 maybe if you were lucky. And that changed over time. Of course, for cross country and on the more aggressive gravity focused, it was a 2.35, then it was a 2.4 and 2.5 and so on. Downhill seemed to settle in a long time ago on the tire width. And if you look across all the available tires, cross country has moved now toward a 2.3 or in some cases 2.4, even at the World Cup level.
Yeah.
So to support that tire in the best way possible, the rim has to get a bit wider. Is 30 the perfect number for everybody? No, I don't think necessarily that it is. We still see really strong sales of our crest, as an example, for the cross-country rim at 23 millimeters wide. We've seen our flow at 30 really close the gap in terms of volume for us. But we also see World Cup Pro downhill riders not wanting 30. They want something just a bit smaller. 28 would probably be ideal. We don't have that for them today, but that's kind of what some of them would want. So, yeah, I mean, 30 is maybe the happy spot since we're all running a 2.4 to 2.6 tire now.
Right.
But I don't think it's necessarily the perfect option for everything yet.
Right. Yeah. Yeah. Racing for sure seems like it's going to be an extreme, if you're talking about that level. But for trail riding, yeah, it does seem like that tire width is what people want. And so that therefore is going to kind of dictate what rim they're going to want to work with it.
Right. And as I mentioned earlier, width and weight kind of go together and along with the durability. So you can't have it all. And does that mean in 30 mil, we can only do carbon to keep the weight in check? That's not accessible for everybody. So to get the benefit of the wider tire and so on, how do you do that in a $300 wheel set?
Yeah.
Only by making it heavy.
Right. Well, yeah, speaking of weight and carbon and expensive, is carbon a superior material for building mountain bike rims? Is it, like if you could afford it, is it better in all ways, or are there some disadvantages perhaps to using carbon over aluminum?
And if you take price point out of it, that closes the gap, I'm sure. But I think there's still the horses for courses situation. Every application and riding style and where you're riding needs to be considered as well. So my basic view is that the ideal rim is the one that meets the customer's needs and expectations. And if that means they're racing enduros where if you have a mishap, you hit the rock incorrectly, not as you had planned at race pace.
Incorrectly, yes.
Yes, and you've done some damage. If you dent that aluminum rim or knock it severely out of true, you get to the bottom of the hill, you whack it back into shape, and you get onto your next stage before time penalty kicks in or something. Mm-hmm. Where if you T-bone that log and your carbon wheel cracked, there's not a lot you can do at that point. Your day's over. So we see it again on EWS riders. A lot of them run aluminum for that fact. They all tried some carbon. Some still run them, of course, but in a lot of cases they backed off the carbon and went back to aluminum. And then you have feel. There's a different feel between them. We've had some very accomplished test riders say that I don't like this carbon wheel because it is too stiff either laterally or vertically, and it causes me to deflect off the line where I know that the aluminum is going to give a little bit. I feel like I get a little more bite from a tire when the wheel's kind of conforming with it. So again, riding style plays into it quite a bit.
Yeah. Yeah. And you mentioned though that with carbon, you're able to get maybe sort of different shapes, or it's easier to get different shapes and profiles for the rim than with aluminum. Does that make carbon better in terms of manufacturing, or is it just that aluminum is, I don't know, more complicated sometimes?
Yeah, well, they both have their challenges, that's for sure. So with carbon, if you're not using a wound style or something of that nature, you're doing individually hand-laid pieces, you can tailor every last aspect of that layup for the characteristics you're chasing. You want really thick spoke bed at the spoke holes, so it never has a failure there, you can do it. If you want a lot of compliance vertically and maintain lateral stiffness, you can do it. You can change every little piece of that layup and get pretty much anything you want within certain limits. With aluminum, you're dealing with an extrusion that has to be homogeneous throughout, and outside of something like what Mavic did with their external machining, or what you see maybe with Crank Brothers and some of the things they did around how the spokes were mounted and so on, there's not a lot you can do to really tweak that profile. It's going to be the same throughout. And it's not to say that they're bad, that it's all bad, but you have to consider things like how do you join the rim. If it's an inexpensive rim with steel pins that join, then you have to have channels that go all the way around. You can't just have those channels at the joint location. So there comes the weight. If it's a welded rim, you can't have a really, really thin spot next to a really thick spot, or the weld will burn through. So there's a lot of things to consider in that profile design for aluminum that aren't factors in carbon. Carbon brings a whole nother assortment of issues, whether it's how, what's the compaction rate, what are the voids, what resins are we using, and how they deal with impact, and is it cured properly, and so on and so forth. So yeah, they both have challenges, that's for sure. Yeah. A lot of people have tried to get into the wheel game as maybe bike manufacturers or just standalone wheel brands, and at some point say, maybe we'll just leave this to the wheel guys. They go the other direction.
Yeah, interesting. Well, obviously, tires have been getting punctures since people started riding bikes, really. And we've had tubeless sealant for a long time now, thanks to Stan. But what took so long for mountain bike tire plugs to become mainstream? It feels like just within the last year or two, we've seen this product becoming more mainstream. There are dozens of companies offering tubeless tire plugs, including Stan's now. What took so long for people to figure out that this worked?
Well, I don't know if it's an issue of figuring out that it worked. It was just reaching that majority of riders where you can start justifying doing the extra bits and pieces that we would all like to have, and so on. I can remember the first time I used the rubber bacon strip, I call them tire plugs, was probably, I still lived in New York at the time, so probably 12 plus years ago.
Oh, wow. The early adopter. As far as I know, I'm in the media, and we haven't seen them for that long. It doesn't seem like it, or maybe just my sense of time is off.
Yeah, I had a friend that owned a bike shop up there, and he was an early adopter to tubeless Jeff at Cayuga Cycler in Ithaca, and he said, "What about these rope things?" And that's what we called it at the time, with a rope. And I was like, "I don't know. Let's try it." And we started using it on the trail, and I remember using them on a trip to Moab back then. And yeah, they did work. And I think now that tubeless, I saw a recent survey where something like 80% of the mountain bikers surveyed were tubeless now.
Mm-hmm.
I remember not too long ago when it was only 20%. So.
Oh, right. Yeah, it's flipped.
Yeah, we're into a pretty sizable majority, and sealant doesn't fix every hole every time, whether it's from lack of maintenance, whether it's a really big cut, just some bad luck, what have you. It doesn't get every puncture, and I wish it did, but in the instances that it doesn't, the plugs are pretty effective. We had a unique take on it, but I just think it was a matter of time and getting that majority into tubeless before you start kind of bringing on all the accessories and other things.
Yeah. I remember seeing a video. I mean, this must have been at least 10 years ago, probably more of it. And I think it was Stan in the video doing a demonstration of tubeless tire sealant. And he was like stabbing this tire with like a knife and, nails and like all kinds of stuff. And, tire was holding air and it was amazing. But then of course you get out on the trail and you get a big enough hole and, sealant is just going to spray out everywhere. And so, yeah, it just seems surprising we didn't figure this out. Like, oh, if you got a really big hole, you need to jam something in it.
Mm-hmm. Yeah. I mean, those demonstrations use production sealant, and Stan loves to stab a tire. There's no two ways about it. But generally, that sealant maybe only been installed in the tire for a couple of weeks to a month or what have you, relatively fresh. We had at some shows and events, we would pull wheels directly off our own bikes, stab them for a weekend, put them back on and go do a ride.
Wow.
It was that effective. But,
yeah.
When you're out in the environment, your tire's wet and muddy, you sliced it on a piece of flint rock or something, different things happen that aren't as controlled as a nail in a tire.
Yeah.
And certainly causes you to think about other ways to deal with those.
Yeah, that's a good point, because once you like actually get on the bike and start rolling, parts of it are going to like stretch and they're going to like pull apart. And I mean, I had that recently with a tire on a bike I'm testing where, the tire sealed up fine. It held air for days and days and days. And then as soon as you get on it, that's when it opens up one of those gaps, and, it's a big gap. And so sealant's just going to flow out of it. What makes the Stan's Dart tool unique? That's your new-ish tire plug solution. What makes it different from the other ones that are out there?
So the big thing that differentiates it from what was available in the market when we brought that out was that the material that we're using to plug the hole isn't the sticky rubber strip, and it's treated with a chemical that reacts with the tire sealant and causes that coagulation we talked about earlier on to happen instantly, effectively. So you have that material, again, kind of like the particles in the sealant that the crystals are doing, trying to seal the bigger portion of the hole. We're putting in a big piece of material, basically, that is impregnated with this chemical. It's safe stuff to use. It's not going to hurt you. But when the sealant makes contact, the fabric absorbs some of the sealant, reacts with that chemical, and causes it to clot and make a permanent seal. Our marketing guys will tell you that it's like growing a tire in front of your eyes, sort of thing. But, effectively, that is the big differentiator. Those rubber strips and so on, they're sticky in nature. They're meant to kind of adhere to the casings a little bit. Again, if it's dirty, if it's covered in sealant, maybe it doesn't work every time. They don't conform as well to the puncture. We use a very conformable material for our darts. And if those the rubber type plugs get dusty and dirty, they tend to not be as effective. Where we encapsulate in our little dart tool to protect the dart itself, so they're always clean and ready to go. And it's that reaction though that really differentiates our product. Yeah,
sounds super cool. And really, really geeky too. It's not just like a physical, I'm going to plug this hole with something. It's actually a chemical reaction that's happening.
It's like you mentioned earlier, it's part chemical, part physical. And trying to come about it from two ways with what we think is just a better solution.
Yeah. So do you have any tips or tricks for dealing with tire issues on the trail beyond just, rolling out with the right stuff to begin with?
And of course, we'll always say, maintain your sealant every couple of weeks or months, depending on your local environment and how much you ride. You want to check your sealant, whether it's ours or another brand. No sense in using it if you're not going to keep it refreshed and so forth.
Yeah. Is there something that causes it to dry out within the tire more quickly? Like hot conditions, is it going to dry out more quickly, or dry air, or is there something like that people can kind of think about?
If you store your bike in the shed in Georgia, it's very humid, but it's also very hot, and that will cause things to evaporate more quickly. If you're frequently inflating the tires, you're introducing new air that can react with the sealants and begin to dry them out. But really, that storage condition is a big factor. The amount you install initially, if you only add 2 ounces versus 4 ounces, well, of course, 4 ounces will last longer.
Right.
Pretty straightforward. And how often you ride, the number of punctures that may have sealed, even without your knowledge. Of course, can use up some sealant. But if you're riding very frequently, you're constantly rotating that puddle. It's continuing to coat the sidewalls and fill in imperfections and so on along the bead area. And that will use some sealant as well. As far as tips and tricks on the trail, beyond maintenance and so on, I would say the initial reaction is always to reinflate right away. Like, I punctured, I heard it, it's still leaking, I'm going to stop, get the sealant to it. Great. You see it do its thing. If you do reinflate right away, as you mentioned before, that casing flexes and stretches back open. It's a little grotesque analogy, but it's like a flesh wound kind of just spreading open again, and then more liquid comes through. So if you can, it's best to ride it at that lower pressure for a little while, allow it to cure and kind of seal the puncture.
It's best to ride it to cure it, or if you just sit there and let the air. I mean, is riding is actually better?
Yeah. The other thing I would say is if you have to inflate on the trail, you can use obviously a mini pump. Be careful with your valves. A CO2 or the big air style inflators. MSW has their non-CO2 inflators and so on. But if you use a CO2, again, you're introducing all that stuff that's wanting to make that sealant coagulate. When you get back home, it's best to deflate, check your tire for any further damage, determine if it's sealed permanently. Maybe you want to add a dart plug at that point and add new sealant and reinflate with just your standard floor pump or air compressor. That will allow your sealant to last longer. Yeah.
Well, I'm going to ask you a personal question. Do you bring a tube with you when you go on a big ride just in case?
I do. I still, 20 years later, still carry a tube on most rides. If it's over a 2-hour ride, I'll generally have a tube with me. I can say I have not installed a tube on the trail. Oh man, this is going to go back a long ways. I still had my titanium Racer X. So we're talking like 2008, 2009 was the last time I had to install a tube on the trail. Now I've given a lot of tubes away to people that should have maintained their sealant or converted to tubeless by now.
Right.
But, I do have one.
Yeah. Well, would you ever bother trying to go back tubeless on the trail? I mean, I know I have friends who do. They carry around, 2 ounces of stands, and, they got CO2 and they try to just mount a tire back up tubeless once they've, figured out why they lost air in the first place. But,
sure, yeah, absolutely. I've done that. So, on the trail bike or gravel bike, I'll have a dart tool, maybe some spare darts, an inflator, whether it's CO2 or a mini pump, and at least 1 2-ounce bottle. Yeah, you can set things back up on the trail. We pride ourselves on our rim designs being very easy to inflate and so on. So we used to do a demonstration with a mini pump at Interbike and Eurobike and so on, just inflating tires with a mini pump to show that you can do it. And there's no reason you can't set it back up if you know what you're doing and you have the proper supplies with you.
Yeah, that's great. So is there a better way to connect tires and wheels together, assuming that the whole industry agreed to work together to possibly come up with some of those dreaded standards?
Well, there is a lot of standards work going on. So you have the international, I don't know how far in the weeds you want to get here. The international standard, or the ISO 5775, has been left to sit for way too long. It actually missed its normal review cycle, but that's been underway for a couple of years now. And then you have a lot of people have probably heard of ETRTO, it's the European Tire and Rim Technical Organization. So they have their standard. ETRTO actually is able to update on an annual basis. ISO is in these 10-year cycles. So right now we're in the process. Stan's as a brand, and one of our engineers and myself here have been involved with the U.S. side, which is ASTM, to try and get this new standard through. We've offered a lot of measurement data and, like I say, some of the CT scans and so on to try and advance these standards. So they're basically trying to encompass what's on the market already with a more standardized dimension at the beach seat and so on. It's not being done in such a way that's going to prevent new innovations from coming along, but I would say we're still, that's hard to guess, maybe 12 to 18 months from that standard being done and published. Of course, I don't feel that it addresses all the problems right now.
Yeah.
But it's a step in the right direction overall.
Yeah. So yeah, I mean, it sounds like some of the existing standards, and especially the new ones, aren't necessarily barriers to innovation, or are there things that, maybe Stans would like to do, but can't because there's like just a lack of intercompatibility in terms of tires or wheels, or do you feel kind of stifled by any of those standards that are out there?
Well, when we started doing rim designs, basically 2002, 2003, we kind of ignored all the standards anyway and started going in a new direction.
Yeah.
Others
and it worked
followed,
out,
I would say. So once the standard is actually established, it helps for a period of time, but things evolve, whether it's material technologies or manufacturing methods and so on, become available or scalable in a way that makes sense. Then that standard sooner or later becomes outdated. So there are some things we would like to see done that aren't possible yet. Coming from the rim side, we're dealing with a fairly rigid structure. I mean, there are things to account for, like when you build the wheel and it compresses a bit, that weren't part of the old standards. They're being incorporated a bit into the new standard. But there are things there that could be done differently going forward for sure. And, it'll be interesting to see how it plays out. I mean, as somebody that obviously we make sealant and that's our thing, I'm trying to think, what's going to put us out of business in 10 years?
Right.
Is sealant even necessary? Is there some new amazing technology that obsoletes sealant? And the same thing with rims. Is there something that somebody out there is working on or has a brilliant idea that hasn't come to fruition yet that just changes our opinion about how this tire and rim interface should work?
Yeah.
We often try to borrow from automotive and motorcycles and so on, and they do some things differently. But in bicycle, we're dealing with very, very light rims and wheels, not at all comparable to motorcycle, a solid steel automotive wheel or motorcycle. Right. We're dealing with tires that have to be mounted by hand. We basically have the only tires that are, of a folding nature. I mean, it's a different animal. So trying to apply some of the bigger equipment or automotive type of thinking to bicycles doesn't really work. We do see that happening from time to time.
Yeah. Well, finally, I want to ask, are there some current problems with mountain bike wheels or tires or sealant that Stans is focused on solving in the future? Like what really bothers you right now when you go out for a ride and you have to deal with your wheels or your tires?
I think much like today's mountain bikes, those of us who have been at it for a little while, today's bikes are incredible. What you can do with them, and by and large, today's wheels are really incredible. There are still improvements to be made in mounting, inflating, how that seal is formed between tire and rim. And there's always room for improvement there. the holy grail of the vertical compliant, laterally stiff. We chase it with a lot of our rim models, but that's something people are always seeming to desire. So I don't think that goes away. The pinch flatting, we talked inserts and so on and so forth. A lot of that is around pinch flatting, not just tire stability. So I think there's some things there that we'll want to work on. And I always think about sealant and what's going to happen with that, and how do we introduce it to the system, or does it get eliminated from the system? And the rims will play a factor there too.
Yeah, fascinating. Well, Mike, thanks so much for taking the time to talk to us and explain to us how tires work and sealant and rims and how that all comes together. I learned a lot, and I know our listeners will as well. So thank you.
Yeah, thanks for having me. That was great.
Well, you can get more information about Stan's products at notubes.com. That's all I've got this week. We'll talk to you again next week.